All right, so I made a mistake earlier. I just wasn't reading it correctly. This is not the terminal voltage. This is the EMF. So E is equal to 1.585 volts. All right, and then I know that I have a 1,000 ohm resistor there, and I have a 0.1 ohm resistor there. That's my internal resistor. And I want to know what is the terminal voltage. I want to know what is the voltage here, right? And so if I find that, then that'll be the answer. What is the terminal voltage? And then it asks you to find the ratio of the voltages. That's just where you divide the voltage by the EMF. Is the terminal voltage going to be bigger or smaller than the EMF? It's going to be smaller. Your terminal voltage is always smaller. It's always smaller by the amount of the voltage that you lose in the internal resistance. So in this case, you'd first figure out what is the equivalent resistance. Then you'd figure out what is the current. And then once you do that, you can figure out what is the voltage across the voltmeter. And that's just that current times the resistance of the voltmeter. Y'all did that in lab. And then once you do that, that is your terminal voltage of the battery. Because you imagine, even though we write it like this is really the battery right here. It includes both the ideal source of EMF and the resistor.